Yeah, do you see the
Yes, ma'am, the
recording
recording has
started?
started.
Okay, great. Okay. Good everybody, let's begin our lecture of the course. Okay, so what we have seen in the first 3 weeks are basics of the programming language, and of course, even given the simple things that we have learned about I mean about the selection statements and a single loop construct, we have been able to do quite a bit of non-trivial things in the class as well as in the lab. For example, we have learned how to decide whether a number is prime or not. You have written code, rather, not learned how to decide. You have written code for deciding whether a given number is prime or not. Computing GCD, not only by a simple method, but by the Euclid's idea. And then you have computation, which is like numerical algorithms, like the computing the square root of a number using the bisection method. And then in the lab, you also did a slightly sophisticated method, right? So today's in this class as well as the next class, the tasks will be like this. We are having modest tasks, but we will introduce the second loop construct, which is the for construct. And again, I am aware that you have seen this, but as with every construct, we are going to look at the details of it. Where can we make mistakes? How does it compare with our earlier known constructs, and so on. And then we have of course seen modifying the control using break, which you have used, and you have used also in your quiz. Today we are also going to see this continue, which allows you to skip certain parts of the loop body that you don't execute. And then we are going to go to nested loops. Where are nested loops required? Where do you need a for inside a for, and so on. And this is what we will see examples for in this week. Okay, so just to recap, last tasks were these, what I had listed earlier. We will revisit this GCD of positive integers. Again, not for the way it is done, but for using a different loop construct and how do things change when you use a different loop construct. So this is the familiar algorithm. You have familiar method or familiar program that we have seen twice now on the Thursday's class as well as Friday's class. So you have two integers, positive integers x and y. We said that we are going to take z, which is the min of the two integers, and then go from I to go from 1 to z using a loop variable which is I, which is initialized to 1, and keep checking whether I is an element which is a candidate for the GCD of x and y. And if I has to be a candidate for being a GCD for x and y, it must divide x as well as it must divide y. If it does divide both of them, then we say that we'll update our estimate of GCD, and GCD is equal to I, and then increment I. So this is what we have seen earlier. We are now going to write this same program using the different loop construct, which is the for loop construct. And it's not difficult. You people must have seen this. We are going to just point out a few things so that all exactly the same page. So the for loop construct has the following syntax. That is, the for word is a keyword. There is statement 1. I write this as statement 1, but this is actually technically an expression. I mean, it can be an expression, but this is statement 1, semicolons, expression, which will be that gets evaluated. Then there is semicolon, then there is statement 2, then this brackets end. There should ideally be no semicolon here, because if you put typically be no semicolon here, because if you put a semicolon, it means the body of the for loop is empty, just like we have seen a semicolon at if, and that can lead to mistakes. Then these braces tell you what you have to do inside the body, and then there can be a set of statements. So this is the syntax of the for loop. How does the for loop semantics of this? What is the meaning of this? Yes. Hello. Is there a question? Okay. So, what is the semantic of this? That is, what is the meaning of this? We will first execute statement 1, which is STMT1 here. Then evaluate this expression. If this expression evaluates to true, that is, it evaluates to something which is non-zero, then we are going to execute these statements which are inside the loop of this for loop. After we are done with executing these statements, we are going to execute this statement 2, which is typically a loop counter increment, where, as we'll see in our example. Then we will again evaluate expression. If it is true, execute these commands again the way we have done. If expression is false, we are going to exit the loop, right? So the test of the expression, except that there is initialization. So this statement 1 can be thought of as initialization. The statement 2 here can be thought of as update of the typically of the loop counter, and these are the body of the these statements from the body of the loop. So just to pictorially depict this, there is this initialization statement. It can be multiple statements. At the moment you see one statement. This is STMT1. Then there is this expression which is evaluated. If it is true, then we are going to execute the body of the for loop. Then we are going to go to the update statements which are given by statement 2, and then repeat this as long as the test expression remains true. So the difference that is there between the while loop is there was only this while loop statements which were there in the body of the while loop. This statement 2 is something that is additionally getting executed at each iteration. This is the difference, and of course, as usual, the changed by some of the statements, either the statements here or STMT2, to make sure that it changes and the loop does eventually terminate. So this is the syntax, the meaning of the while loop, and of course the flow chart. Any questions here? Okay. So let's get back to that simple method of computing GCD. It may seem a little irritating. We are going over the same example. To have that same example, nail it down and do it using different things. So here is where we have used, instead of the while loop, a for loop. So we had this I which was being initialized. So instead of doing the initialization outside the loop, I'm doing it in the place where there was it was statement 1. Note that I am not only initializing the variable I am also declaring the variable, because I'm saying int I is equal to 1. This is also allowed, and some of the older compilers make it, but now the new compilers GCC will allow this. Once you have initialized this, we are doing the same thing that we were doing. If I mod x mod I is equal to 0 and y mod I is equal to 0, then we update our GCD estimate. After this, the I++ was here earlier in the while loop, but now we have moved it to the statement 2 place, where it allows us naturally to increment the loop counter, and then it again checks whether I is still less than or equal to z, and this goes on. So this is translation of the while loop to this for loop construct, the same program which we had written earlier. Any questions, any comments here? Okay. So as I said, at the end of this body of this loop, that is all these statements, once they are done, then we are going to execute this statement I++. There is no semicolon here. Note this. I mean, this is how the syntax of this statement is, syntax of the for loop is. And this statement 2 is going to get executed. In our example, it is I++. So this I++ here can be replaced in this example by plus I is equal to I plus 1, I plus is equal to 1, doesn't matter. This is a unit, or this gets executed as a single statement, and then only after it is executed you are going to check the test expression. So it doesn't matter whether you write plus I or I plus at this place, or I is equal to I plus 1. Any questions, comments here? Okay. The
Ma'am,
next thing is that,
hello, ma'am.
yes.
Does it mean post increment and pre increment both don't have any effect, no, ma'am? Like it acts samely. I mean, react in the same way, right? Post increment and pre increment.
So here, so in this context, they do not have a difference. I'm not saying that pre-increment and post-increment are the same, because if you had done something like somewhere else you have done A is equal to I plus plus versus A is equal to plus I, those are different things. They mean different, right? We have seen this earlier. In this context, if you write plus I or I plus plus, it doesn't matter, because you are just taking I, incrementing it, and only after that statement. Yes, that is what I have written. So we can replace I plus plus using any of plus I or these statements. Does it answer?
Yes, ma'am.
Okay. So the next thing that I want to mention is that while we have written statement 1 expression and statement 2 here, all of these are optional. That is, they can be left, any of them can be left empty. In fact, all of them can be left empty. And if everything is left empty and the expression is not there, then it is, I mean, there is no expression. You have just said for comma, for semicolon, I mean, just nothing, semicolon, nothing, semicolon, then the completion brace. Then it means that you have an empty expression which is assumed to be evaluating to true. So then it is an infinite loop. Then the onus lies on your body of the loop to make sure that the loop terminates. Otherwise, it is an infinite loop. So all of these are optional things. You may decide to skip one or many of, I mean, one or multiple of them, including all of them, right? But again, it is not, I mean, it's not about whether you I mean, yeah, you can skip all of them, but you will use this for loop where it is more natural to use, and we'll say what do we mean by natural versus an unnatural use of for loop. Any question here? Okay. Yeah, so I'll come back to our Euclid's method of computing the GCD, and again, I have omitted the parts which we understand. So we are doing scanf and so on, but we are assuming x is greater than or equal to y. If x was not greater than equal to y, then we would have swapped it to ensure that this condition is met. And then we have written this loop earlier, that is, while x mod y is not equal to 0, we update x to be x mod y. And then we know that x is always going to be less than y because of this update. Therefore, we are going to swap x and y. And this is done using the temporary variable. Temp must be appropriately defined. Xy must also be and declared outside the loop. All of that I have assumed. So let's now convert this into a for loop. We have already written this using while loop. We have seen the program execution. Okay. So the way I have written it is to illustrate the empty conditions. So in this case, I don't have anything to initialize. X has been already scanned. So I have already scanned X and Y outside the loop. So I don't have anything to initialize for X and Y. Temp also I don't want to initialize. There is no loop that is going on. So the only thing that I'm going to do is I'm going to test if X mod Y is not equal to 0. If it is not equal to 0, I'm going to go inside the loop, change the things the same way I was doing here. And because the test expression is x mod equal to 0, and the body of the loop in fact does change x, therefore there is nothing else. I don't have to do an increment of I or anything. In fact, writing another x is equal to x mod y is going to be incorrect here, right? So this is something, so we are doing exactly the same. again, at this stage, because x is going to be smaller than y, we will swap x with y and then continue this for loop. So there is no statement 2, there is no statement 1, only the expression is tested here, which is what was the expression tested in the while. So one question is, can we get rid of this in the small snippet? Can we get rid of this and write down the for loop with empty, statement 1 empty, expression empty, statement 2 empty, and so on? Can we do that? So what I want you to do is think about it and write down in the chat what can you replace this for loop without changing it too much. I mean, you will have to change something inside the body of the for loop. As I said, sorry. So please don't. I mean, yeah, it is creating some echo. So please write down in the chat. I will look at the answers and then we can discuss. Okay, so my voice is breaking, is it? I'm sorry. Is it okay now? So Kaushal, is it okay?
Yes, ma'am, it's fine.
Okay, so was it breaking for a lot of time?
No, ma'am. It's fine for me.
Maybe it's a connection problem with some of the students. Okay.
Ma'am, can you repeat the question?
Yes. So I hope everybody sees that we have written this while loop using the for loop, right? So in the for loop, so Navaneet, is it possible? Do you have a question? Okay. So the question or the task that given is, can you get rid of this expression being written in the place where there is, I mean, the second place where there is expression for the for loop, and modify the body so that this becomes for nothing semicolon nothing semicolon, complete this brace and then inside, right? That is the question.
Ma'am, like if we add an if statement inside stating x mod y, not like if
Yes.
x mod y not equal to 0.
Ishtartha, just let me interrupt you. I request you to write down your answer in the chat so that everybody gets time to think about it.
Okay.
Sorry to interrupt you, but I want everybody to think about it. Yeah, so you're on the right lines, Ishtartha. I think I just want everybody to get a chance. Yeah, so I see the answers that you people have written, which are again on the right line. One of the ways to do this would be that we want this body of the loop to get executed only when x mod y is not equal to 0. So so if this x mod y turns to be equal to 0, you want to quit the loop. And when is it that you want to test it? You want to test it, I mean, you would not have even entered the loop if x mod y is equal to 0. So because your expression is empty, if you are going to if there is no expression here, you are going to enter the for loop. So as soon as you enter the for loop, you can check if x mod y is equal to 0, which is the negation of this condition. Then you break. If this happens to be equal to 0, you just break out of the loop. If you did not execute that break, it means that x mod y is not equal to 0, in which case x is equal to x mod y. Then temp will, I mean, you swap, of course. Then there is no statement 2 which you want to do, because there is an empty statement 2, and then you again enter the loop in which you will again test if x mod y is equal to 0. If it happens to be, then you just break and you just continue. So this is one correct way of modifying this loop. If you are forced to have this as an empty, I mean, again, I'm not saying this is a nice way of writing this program, but I'm saying that it can be modified to use the for loop with all of the things being empty. And this is an unnatural usage of the for loop. In fact, the way the Euclid's idea works, it is most natural to write a while loop for implementing the Euclid's idea, whereas it is natural to use the for loop for the simple GCD idea that we have. So I hope this small example illustrates that you are computing GCD first. It is two different algorithms that we have already observed in the last class, that they are two fundamentally different algorithms. They perform completely different in terms of the efficiency. And if you want to implement them, one of them is a natural use case for the for loop, the other is for, although what we are showing here is each of them, the for loop and the while loop, can be interchanged by doing appropriate modifications, and we have shown it using this example. Okay. So any thoughts, comments on this?
Ma'am, can we write x mod y as the update expression and do just the swapping part inside the loop, ma'am?
Okay, so what is your what is your this thing? So let's understand your proposal. So you have for, there is empty, nothing to be done in statement 1, x mod not equal to 0. And then inside the for loop, you don't have x is equal to x mod y. Yeah, you don't have that, right?
Ma'am, no, ma'am. Inside the for loop
Okay.
as the update expression equals x. I'm doing inside the loop, ma'am. Will that work?
Yeah, so I'm just going over it slowly. So is it Ashwath?
Yes, ma'am. Yes, ma'am.
Okay. So I request all others to mute if possible, because otherwise it's creating noise. Okay. So if please follow me closely. So it is, there is an empty expression, x mod y is not equal to 0. Is that what you have in mind? I am not able to hear you if you are speaking. So do you have x is equal to x mod y inside the loop, or you don't have it? Okay, Ashwath, so I think we lost you, at least at the moment. I don't hear you. So I will move on for now in the interest of time. If required, we'll take this offline. Kaushal, are you able to hear me?
Yes, ma'am.
Okay, sorry. So I see on my end there is network issue. So did I lose connection in between? Okay, I see that people are saying that the voice is not clear. Uh, okay, just give me a moment. I'll pause this record and I will possibly stop my video and try to see whether the voice. I'll actually just stop the video. And is the voice better now? So Harish Krishnan, right? You have said that the voice is it better now?
It was breaking before, ma'am. Now it's all right, ma'am.
Okay. So for the moment, I will just stop my video because maybe it is using too much bandwidth. But I'll see if this is better, and if it is okay, then I'll start my video again. Yeah. So can you just give me feedback after a few minutes whether the voice is okay?
Okay, ma'am.
Okay. Okay, good. So yeah, I think we lost Ashwath in between. I'll just move on for the moment and then we can come back to
Ma'am,
it.
I'm
Okay.
sorry, my network had an issue in the between. Please excuse me.
Okay. Yeah. So sorry. Okay. What is the so you had some question, right?
Yes, ma'am. Yes, ma'am.
Okay. Ashwath, just in the interest of time, I think I'll take it offline. Is that okay?
Yes, ma'am. Sure, ma'am.
Yeah, sure. Okay. Sorry, today I also have some network issue. We in fact had power outage just before the class. Okay, so I'm coming back to this. So we have looked at, so what we have learned in the last examples is that I just want to summarize that we have this while and for loops and they can be interchanged, and with care you can modify one into another, and there are use cases when one is more natural for the way the algorithm or the thought process is, and therefore you should choose the appropriate construct. Okay, so I'm coming back to this simple method of computing GCD. So this simple method of computing, I mean, we know that we had this integer I which is running from 1 to z. We are checking if x mod I is equal to 0. Recall that we have this x mod I equal to 0 and which is the which is this logical and. This we required because of the short circuiting. We know that if x mod I is not equal to 0, then it is not even going to compute this y mod I. I mean, it is because we know that this is false and something, so it will always turn out to be false. Then we are not even going to execute that. So for the moment, assume that this short circuiting were not there, or it is, I mean, just for the moment, if it were not there, then you are saying that you are checking x mod I is equal to 0 and y mod I equal to 0, and if that is both of them are true, then you are going to go into GCD, updating the GCD. But what the thought process is that if I does not divide x, then there is no need to even check whether I divides y, which is what is the implementation. But for the moment, just assume that this short circuiting is not available or your language doesn't support it. Then we want this thought process to be implemented. If I does not divide x, then there is no need to go and check whether I divides y. Note that in this simple example, this is a simple operation, but in general these can be big things that you are doing, and you would want to skip some parts that are done if one of the conditions is not true. Similarly, if I does not divide x, then we have already ruled out the possibility that I can be a candidate element for GCD. So that is safe. That is, we don't want to update our GCD if I does not divide x. However, even if I does not divide x, I must be incremented, right? So this is what is the thought that we have, that if I does not divide x, then there is no need to even test whether I divides y, which is already implemented using our short circuiting. However, also know that if I does not divide x, then I is not a candidate for GCD. But if I even with this, irrespective of whether I divides or x it divides y or not, it must be incremented for the loop to go further and not get stuck, right? So this is the thought that we want to implement, and here is where we are going to use this command, which is the continue command, which allows us to change the control in the body of the loop statements, and this is how we will use it in this small example, and then also show the syntax, show the semantics of the continue command. Okay,
Ma'am?
so the way,
Hello,
yes.
ma'am. Does that mean if statement is false here, I won't be incremented in this for loop? Is that true?
Okay, so that is why the question that Kanikeshwar has is here in this code, right? Is that what you're asking?
Yes, ma'am, in this code, yeah.
Okay, so in this code, what is the, so let's go back to the semantics of the for statement. The for statement says that, the for construct says that you are having this initialization, which is this, then you are going to test whether the expression is true, which will be true in the first case, in a typical scenario, 100. Then you are going to go inside the body of the for loop and execute that, and whatever happens to the body, it doesn't matter, right? It is going to go to the update statement, which is this statement 2 that we had written in our generic format of the for loop. Once statement 2 has been executed, it is going to go to the test expression. So now can you answer yourself what happens with if I does not divide, or does it depend whether it's going to be, does it depend on whether I divides x or y or both?
Yeah, that is important actually. If it's going to be automatically incremented, then why do we need an extra function to do that?
Where do I?
Now you are saying we do this continue function, no, ma'am?
I'm not saying continue is going to be used for that. I'm just saying that if, okay, so I have made a few assumptions before I said this, that actually I made this clear that in the current way it is written, if x I is not equal to 0, that is I does not divide x, then our language, the way the support of the languages or the way the AND is implemented, you are not even going to check whether y is divisible by I, right? Because this expression turns out to be false. So false and something is always going to turn out to be false. Therefore, you are not even going to test whether y is divisible by I. But for the moment, assume that this short circuiting is not available, in which case the thought that we have is x, if I does not divide x, then there is no need to check whether I divides y. If I does not divide x, then I don't have to update the estimate. But irrespective of what happens to this division, that is the result of this division of x by I and y by I must increment the loop counter. And that is how we are going to write the code to explicitly say that. Clear? I'm not saying that we are going to have an additional thing of, so let me just show the code and then possibly you can ask the question again if it is not clear. Okay, so so what we are going to do is have the same loop run from 1 to z. If I mod x mod I is not equal to 0, then you simply continue, because you don't want even y mod I to be tested or anything below to be done, except that you want the loop counter to be incremented. So that I'll come to. If y mod I is not equal to 0, then again continue, because it doesn't change your estimate. Remember, when is y mod I even tested? Only when x mod I is equal to 0, because if x mod I is not equal to 0, then we have already skipped remaining part of the loop. So continue will skip the remaining part of the body of the loop and go where it will go to this update statement. So it will go to this update statement, or stmt2 in our template of the loop. It will increment the loop counter. It will again test whether I is z. If it is less than or equal to z, then it will do all of this. If you reach this place, that is, if you are at this place in the control, then it implies that I x mod I is equal to 0 because you haven't skipped the remaining part. Also y mod I is equal to 0, and that is where you want to update the GCD. Therefore, you are not checking anything. In fact, if you are here, it must be the case that x mod I and x mod I as well as y mod I equal to 0. So we are not testing anything here. So the important thing here to remember is that where does this continue take you when you're writing a continue in the for loop? It is taking you to the update statement or the statement 2 in our standard form of the loop. It will therefore do whatever is in the statement 2 and then do the test expression. So yeah, so please stare at it. If there are questions, let me know. We'll go back to the form of the continue statement in general, but yeah. Okay, so assuming there are no questions on that code, I just want to show the, if you have a for loop where again what we have written here is the, let me annotate this. Yeah, so we have this statement 1, which is sorry, I don't think my annotation is working. Okay. Yeah, so we have this statement 1 which will get executed. Then there is this test expression which we are testing. Assuming that the test expression is true, we are going to go to this inside one statement which is going to get executed. And if there is some test condition, again this will be some expression. I'm not writing it as expression, but if something is true, then you are saying continue, right? Which means you are going to go to continue, skip the remaining body of the loop, which is, that means inside 2 statement is not going to get executed. Skip remaining body of the loop. However, it will go to STP2. This is going to get executed and then go to the test expression. So what I want to say here is that whenever there is a continue here, inside, not here, sorry. Whenever there is a continue inside the body of this for loop, it is going here. It will skip the remaining parts of the statement and go to the update expression. Then go, so there is some remaining part which is going to get skipped, but it will go to the, after that continue, it is going to go to the update statement, do whatever is written in the update statement and then do the test expression. So this is something which is important. Continue skips the remaining part of the loop but does not skip this statement too. So is that clear? Okay. Assuming there are no questions, this is clear to you. Okay, so this is something which is our quiz question. You have seen, all of you have seen this in the quiz. So yeah, so this is something that all of you have seen. I think there was in some of the versions or in this, there was a typo where this was not I is less than or equal to 100. It was strictly less than 100. But if you want to print out the numbers from 1 to 100, including 100, then you should have less than or equal to 100. That is, sorry about that. But that was not the part, I mean, that was not the thing that we wanted to test in the question. We wanted you to fill up this code such that it prints out numbers from 1 to 100, excluding multiples of something. In this case, I have taken this concrete example of 3. So if I mod 3 is equal to 0, do you really want to skip this loop? You want to skip the printing part for sure, but remember, this is not a for loop. It is not something that the increment statement is written as a third statement here. So therefore, you want the loop counter to be incremented, and this is where why I said that irrespective of whether I divides x or I divides y, I must be incremented. So this was something which was already done for us in the for loop. This doesn't happen automatically in the while loop. The correct fill up here was I plus plus, and then the break here, which I think most of you got right. But some of you, I think, got into this and wrote continue. In fact, I had clearly mentioned that since we haven't taught continue, continue is not a part of the quiz. Never mind. I mean, I don't. It is not that you should not use something which is not taught. You can write what. But it is incorrect to write continue, because if you write continue, then it is going to skip the remaining part of the loop, but it's only the remaining part of the loop where you are doing I plus plus. So you cannot do just continue here. You must do I plus plus there. I mean, I plus plus and then continue doesn't matter because there is anywhere else. So this is something I want to bring out, that the use of continue in a while loop has to be done here. You have to make sure that the expression that you want to change is indeed moving ahead or getting modified. Otherwise, you can get stuck into the while loop. So the correct answer here is I plus plus break. Of course, as I mentioned earlier, there is some small issue with the question itself, but that was not the point of the question. Okay, so any question, comment here?
Just one thing.
So,
In fill up one, is the answer continue or I plus plus?
Sorry.
In fill up one, I don't get it. How is it continue, man? You were saying I won't be incremented, so
How is the answer continue? I'm not saying that the answer is continue.
okay.
In fact, some of you have written it as continue. Okay, so the question that is there is, let's understand what will happen if we use continue. Okay, so let's take I is equal to 1. We start with I is equal to 1. If I mod 3 is equal to 0, which is not the case, therefore we'll go to else. If I is okay, great. So you will print I, which is good. If you will increment I, you will go to 2. The same story, therefore you will print 2. Now I is 3. Let's go here. I is equal to I mod, I mean 3 mod. So where does it go to? It again tests the expression in the while loop, and it checks whether it is true or not, which is always true, and therefore it goes into the while loop again. Now what is the value of I? I remains to be 3, and it continues to remain 3 because there is no place where you are going to change I. So therefore I continues to remain 3, and it will just be 3 mod 3 is equal to 0. It is indeed equal to 0, so it will just continue and it will keep continuing but do nothing. Is that clear to someone who asked what will happen? Therefore, this is a loop which will get stuck but not move ahead. And that is not what you want. So in fact, what you want to do is do an I plus plus here, and then of course when you have finished looking at all the integers, then you want to do a break. Okay. Yeah, so this is how this I mean, I just want to bring out, when there is a while loop and you have a continue, it goes to the test expression and tests it again. In the case of for loop, I'll again try to annotate this. I deliberately kept it like this. So yeah, so you do this continue, it is going to go and do this update, then do the test expression. And of course, I also want you to observe that these are not commas but semicolons that you should be using. Annotation skills are very bad, but I want you that these commas are not correct. These are the semicolons that you should be using. And the continue takes you to the update statement, and therefore if you have an increment in the loop there, that will work out correctly. Okay, so we run out of time. Quickly to summarize what we have said. Yeah, so what we have as today's learnings are that we have looked at this for loop, the of the for loop semantics, and seen some examples. We have seen this common theme of the computing GCD problem, where we saw that for and while are natural cases for the two different methods that we have studied. And these two different constructs are interchangeable, but we need careful modifications. And finally, we saw this continue, which allows us to skip parts of the loop, but it has to be used with care when you're using especially the while loop. Okay, so this is all I wanted to say. We'll meet at 3:15 again for the lecture. And I request Prakhar and the other CRs to just collect any feedback if any of the students have it for the class and attend the class committee. Okay, so I'm going to stop the recording. If
Ma'am,
there are
3:15 only, ma'am.